Thank you.
phone.
Thank you. So feedback, let us say automatic control and say higher SNR. ठीक है? Then what is essential for the feedback to be effective? अपन ने देखा feedback, we need the feedback can do these two things. So what is happening in the system? पहले दिन first thing we looked at that. Because those things should, as soon as somebody says those things, it should come in your mind. As soon as somebody says feedback, those things should immediately pop in your mind. That anybody says I am using feedback control, you should check on these two things, whether it will be effective or not. You are reading research paper, you can find out whether feedback will be effective or not, focusing on those things. हाँ तो बताएं, feedback is effective under which conditions? First thing we saw, first day. Operational amplifiers, transistors, does it bring anything to memory? When is feedback effective? Pardon? Very good. It's the starting point. आप कभी भूलेंगे नहीं. When I said the gain is high. So gain is high is one of the primary requirements of feedback. Right? So your feedback equation is what? Ys over Us is 1 plus Gs Cs. No. So when will output follow input? When will output follow input? What conditions do you think should be there? When is output going to follow input? Yes? क्या इसमें देख के आपको क्या लगता है कि output will follow input when CS does that make sense, sir? ये बहुत ही फंडामेंटल है मैडम. डज इट मेक सेंस? सही में अगर ये दिस इज ग्रेटर देन 1, देन व्हाट विल इट बी अप्रोक्सीमेटली इक्वल टू? So your output will follow input. That's one of the most fundamental thinking process. Feedback, when is feedback effective? Feedback is only effective when it is in high gain problem, high gain. अगर high gain नहीं है, तो output will not follow input. So high gain is the primary requirement for feedback. So then, as you know, this is a complex variable. So this is technically not right, because CSGS is some funny kind of thing, but you can do that. I mean, limited. You can say that. But all those things are technically, you have to be more precise. But to get a mental conception of when is feedback effective, it is only effective in the zone where there is high gain. ये बहुत ही important property है. Okay, feedback high gain. And when high gain happens, what happens? Instability. Thank you very much. Instability. And to take care of instability, what do we need to do? We have to have a model. And a very good way to model is frequency response. So those are the basic things we did about feedback. Right? Then we did a few things about synchronous machines and things like that. And then yesterday also I saw in your tutorial that you had this plot, right? Power. Right? Yesterday आपने tutorial में किया था. So can you tell me, or if somebody comes and asks you that why this funny shape of the curve, how would you explain? ऐसा क्यों होता है? What is the property? Yeah? Diffusion, yes, very good. And आप बताएं पूरा in a few sentences, complete explanation.
When diode becomes forward bias, that's the time when it goes down.
Very good.
Before that, it starts to oppose.
Very good, sir. So if I can say it in my words, we connect diode in forward bias, right? And the current due to solar radiation is constant. So because that current is constant, the more you increase the voltage across the diode, the more power you can extract. And because it is in this fashion, so current is going that way, so it is charging the battery. So you're extracting more power, but as soon as the diode comes into action, as you said, diode forward bias current kicks in, the net current going through the battery becomes smaller and smaller, and you lose all power. Okay, so we saw that. Good. Now, what did we see about machine learning? What do you remember from yesterday about machine learning? What are the things? So what did we look in machine learning? What is the topic we covered yesterday?
Hebbian rule.
Hebbian rule to do what? What was the purpose of Hebbian rule? Pardon? Linear equation, आपको उसका technical चीज बोले ना. What did that do? What was the word we used again and again and again? What was that line doing? Practically speaking. Classifier. So we yesterday looked at classifiers. How to take groups of points and classify them. Okay? So classifier. So we look at one classifier, Heb's classifier. What was the attractive aspect of this classifier? Right? Pardon? Update, yeah. All those are true. But what was the key point which got people so excited? Key point which caused so much excitation. Heb's rule. Compared to what Widrow did. Yes? It classifies, yeah, well mannered, that might be true, but that unsupervised learning method. You simply use the output, delta W1 is simply eta yx1. So you are not telling them how to classify, it classifies itself. It's a big deal. Unsupervised classification. And that's what got people excited. that machine can pick up. We don't have to tell anything to the machine, and machine can do everything on its own. So that was a big deal. And still today, unsupervised classification methods are a big deal. People use them all the time. So that's where. And then we looked at this. So then we looked at supervised classification, where we had the data and the true output, desired output. Right? And we minimized this error to do what? We took this is given, this is measured. So we have both these numbers with us, they're available as numbers to us. And then this is what we called as error. And then how did we minimize the error? What was the algorithm? What was the method? What was the idea? Pardon? Taylor's theorem was the theoretical tool behind, and where did we end up? You're right. That's how we started. But what was the method? वो आएंगे अभी, पर what was the, from Taylor's theorem, where did we go? Thanks for reminding me. Steepest descent method. Okay, from Taylor's theorem we went to steepest descent method we can use. And in neural networks, what did we change as a result of this steepest descent method? What did we fiddle with? What did we do to reduce the error? Direction, and using that, what are the quantities we changed? कुछ बदला था ना अपन ने? क्या बदला था? See, we have to change something to reduce the error, right? Weights. We had changed the weights. So we had changed the weights and biases. And what was the algorithm which we said was extraordinary, which made this? The method we used to change W, the steepest descent was the principle we used. The neural networks, we didn't say shallow or whatever, we have not come to that. But what was one technique we discussed at the end of yesterday's talk? Withdraw what? What is that method called? Yes? Back propagation. This is the key to the success of neural network training. You train a neural network, and the key is back propagation, and via back propagation it can be done very efficiently. You can modify all of them at a time. And can you tell me the idea of back propagation from here, W1, W2? In your memory, how, if you want to explain back propagation using these symbols, how would you explain it? एक मिनट है, उसने email. Right. Well. Just a minute, eh? एक मिनट. So I'm just trying to send Makaran ji the latest files. Here. क्या है ये? Okay. या आपको मकरन जी आ जाएंगे फाइल्स. हाँ मिल. There some scripts. Okay. So can you describe to me how back propagation works? It's a very important thing. How does it work? Yeah? Well, I suppose in your mind you could be right, but how could, I mean, let me put it in my words. We first update W1 and W2, and then we back propagate it to update W11, etc., etc. So we go from right to left and back propagating the updates, and that way it becomes more stable and it is the most useful one. Okay, so now that being done, sir ne yaad dilaya, what is the basic of machine learning? We have to revise it again and again. I think it will be a good idea. So what are the basics? What is the basic idea behind machine learning? Absolutely at the bottom. Yes sir, aap bhi bataएं. What are those 3 steps?
Guess the variables. Update the solution.
Guess the solution, and second is what? उसके पहले अपडेट के पहले कुछ करना पड़ेगा ना. इनिशियलाइज तो कर दिया गैस. फायरिंग द, अरे वाह, वेरी गुड. मैडम बोलने लगे अब. वेरी गुड. एरर मिनिमाइज हो गई. वेरी गुड, वेरी गुड, वेरी गुड. फाइंडिंग द एरर, use the error to update the solution guess such that the error is reduced. That is whole machine learning. In most other methods, when we are doing by hand, we want to have very quick methods to reduce the error. Very quick methods when we are doing by hand, because we have got a limitation how much we can do. But when we are doing by machine, 5 million, 1 million, 2 million iterations doesn't mean anything. It will just chug along happily. So as long as you are improving at every stage, no matter how small, you are getting closer to the solution. And that's the whole idea of this machine learning thing. that most of the theory existed for a very, very long time. What they are using for machine learning, artificial intelligence and all that. But now many of those methods they have used for which theory does not exactly exist, but they want to try. And if the theory exists, it exists in such a restricted way that we can't make use of it, but we can make use of the ideas behind the theory. Okay? Now,
We used to do with Newton-Raphson and the Gupta, we are using the same process.
when you use steepest descent, exactly same. Rangekutta is different, but Newton-Raphson exactly the same.
What is difference? Why it is machine learning and why?
Very good. Newton-Raphson you can only do if you have got an analytical definition of the function. If you don't have analytical definition, you can't do that. So now here, you are not, so that's a very good point. सब समझ गए? अगर न्यूटन राफसन ही करना है तो ये झंझट क्यों कर रहे हैं? That's a very good point. Anybody who wants to contribute to this discussion? What are we, and that's a key point which I had thought of discussing. So what is it we are doing when I say that to do Newton-Raphson, the function we are optimizing has to have an analytical expression. वो सब समझ गए? Analytical expression से क्या मतलब है? What do we get if I've got an analytical expression of a function? क्या कर यहाँ ऐसी कौन सी चीज है which I cannot do if I don't have an analytical expression of the function? ये स्टेप जितने अपन ने किए हैं वही करने के हैं और कोई नई चीज नहीं कह रहा. कौन सी ऐसी चीज है which I cannot do if I don't have an analytical expression? What was the one and only one method we have for reducing error? What is one and only one method we have for reducing error? We don't have anything else. Only one method. Pardon? Yeah?
Steepest descent method.
Steepest. Oh my God. आप लोगों का एक्सेंट कमाल का है. आप मराठी है? हाँ. Sorry. मैं मुझे मजाक कर रहा हूँ. Steepest descent, correct. If the steepest, मैं भी आपकी तरह बोलने लग जाऊंगा. Steepest descent method, where you have to take derivative. If you don't have an analytical expression, you can't take a derivative, right? So now what is it equivalent? What is equivalent thing we are doing here? That is the crux. That is the heart of the problem. What is it equivalent we are doing here? We do not have an analytical expression, but we are doing something equivalent here. What are we doing? And this is everything depends on this. Let me do that. क्या है H1 था, H2 था, भूल रहा हूँ ये क्या था, but that's all right. X1, X2, W1, W11, okay. W12, W21, W22, W1, W2, right? Something like that. This was our neural network, right? What we had a look. There could be millions of types of neural network. So what is it equivalent we are doing here? What is the equivalent thing we are doing here is we are assuming that this neural network is an analytical approximation of the function we are minimizing. We assume this function is given by that neural network. Okay, function is given in the sense y equals to h1w1 plus h2w2, right? So y1 equals h1w1 plus h2w2, right? That's clear? And that's a function, mathematical function. So we are assuming that this entire neural network gives or approximates or is as close as possible to the function we are optimizing. Okay? So that's why when we put an input, output comes. When we have trained the neural network, we get the desired output because we have trained it with the function. So we are approximating analytical function. So we can do this only if we have got analytical expression. If you don't have, neural network is approximating those functions in an analytical way. Why is it analytical? Because you can take differentiation. You can differentiate, right? Yeah, yesterday we did differentiated. So because you can differentiate it, neural network represents an analytical function. And that is what the heart of neural network business is. There is a theorem which says that a neural network can approximate an arbitrary analytical function. There is a theorem. Okay, that Anil Anand Swami's book I recommended yesterday that gives that proof. And that's the key. As long as they're analytical, you are all right. Or otherwise also there is a great, so the proof would exist for a class of functions. But in practice, you may be able to approximate many more functions than that. And that's what neural network really is. It is approximating a function. And because of the structure of the neural network, the weights and whatever it is, what not, we have got an algorithm to update the weights and to reduce the error. That algorithm is very convenient. And somehow we think that it captures the essence of the problem. Somehow in its weights and all that structure, it somehow remembers or somehow learns of that. So people are not 100% sure what's happening there, but people are very confident that it learns in a very unique way. Right? So once you train it, it has got more information sometimes than you think it has. Okay, so there are many things people have been able to get out of neural networks. They didn't think that it was trained for that purpose. Okay, but very useful information. So that's all a big thing. People who will teach neural networks and all that, they will teach you. But this is the background we need to know to do our business, power system business. Right? Any questions? नहीं? अब थोड़ा काम करना पड़ेगा. Right? पेंसिल पेपर निकालना है, थोड़ा काम करना पड़ेगा. ओके, क्या काम करना पड़ेगा? I'll get you to solve a small problem using dynamic programming. The thing which is behind all this, the dominant idea is dynamic programming. The dominant idea is dynamic programming. Does anybody remember or have come across dynamic programming? Whole business of neural network is dynamic programming principle in one way or another. So it was given by Richard Bellman in 1960s. And it is so simple. So that is the trick, or that is the, how should I say? people who are very clever can see the depth in simple things. आप मेरे को बोलो, मेरे को लगा यार तो क्या है, but people who are clever, because he had been pushing it. Unfortunately, he did a huge campaign to have cancer research using computer, this optimization method, so that optimal drug is injected into you. Chemotherapy होती है ना? So he was a big proponent of using computers to find the dose to be given based on many optimization factors. But unfortunately, the man himself died of cancer. His name is Richard Bellman, very famous mathematician. So he came up with that principle. Principle is very simple. So anybody who has come across that? Okay, the principle is very simple. Let me see if I can write it in a simple way. We will have a look at this principle in the slides and all properly. But this is basically the principle. And here I am not telling about actions and all that, we have to take actions. What the principle says is that my action, minimum or actions, all actions, basically what it says is that आपके यहाँ चौराया है बाहर निकल के, so it does not matter how I reach that choraya, the optimal path from then on is fixed. ये बहुत basic common sense है कि once you reach that intersection, it does not matter how you reach there. The shortest distance from there is the shortest distance. बहुत सीधी बात है, मतलब I don't think that there is any human being who does not do that. आप कहीं जा रहे हैं और कहीं गए तो आप ये नहीं कहेंगे नहीं मैं तो वहां से आ रहा था, शायद shortest distance would be different. It has to be the same no matter how you reach that intersection, right? So ये how you reach, the cost of reaching that intersection, that you minimize. So what it is saying is, जैसे यहाँ से आपको कहीं जाना है and you know the shortest path from your VNIT gate to airport. So you don't have to, so when you are doing an optimization problem, you are only worried how to reach the shortest distance to the VNIT gate and not to the airport. So you break the problem into parts. So वहाँ से यहाँ तक, यहाँ से यहाँ तक, यहाँ से यहाँ तक, so you find shortest distance in, so your optimization problem gets broken down into small parts. Okay, so that's basically it. That if you want to go to the airport, you know the shortest distance from VNIT gate to the airport, you only have to worry about shorter distance from where you are to VNIT gate. That's all your problem is. So you break down your optimization problem in this way. So to get a better idea about this whole business, let's look at a problem. और वो आपको सॉल्व करना है. So we have got this problem. Our load looks like so. Just 4 hours. Between 0 and 1, the load is 5 kilowatt. Between hours of 1 and 3, it is 7 kilowatts. Between 3 and 4, it is again 5 kilowatts. The tariff is 5 cents or 0.5, whatever unit you want to use. 0.5 between 0 and 1 between this 2 and 3, and again 0.5. And the battery available is 2 kilowatt. So what you want to do is you want to use the battery to minimize your cost. Okay, what you pay to the utility, you want to minimize it. You want to use your battery. Right? Problem समझ आ गया? No? Sir, load and tariff, you understood those curves, right? And now you have got a battery with 2 kilowatt charge and discharge. So if you use your battery here, what will happen to the tariff cost? No, if you use battery here, if you discharge your battery here, what will happen to the tariff cost? What will happen to the cost you pay, the price you pay to the electricity company? It will reduce, right? So the strategy is to charge here and discharge here to reduce the electricity bill, right? But there is a constraint. When at the end of 4 hours, what do you expect battery capacity should be? State of charge of battery. Is there a constant on that, or we don't care? We are using the battery during these 4 hours. At the end of 4 hours, is there a constraint on what battery charge should be? Or we don't care? It is drained, or it is what, we don't care? Or do we care? Care? Very good. ये I am not मत करिए आप. दुनिया में सभी गैस कर रहे हैं. दुनिया में हर व्यक्ति गैस कर रहा है. तो ये आपका गैस किसी और के गैस से कमजोर है, ये मत मानिए आप. You are just as competent as the next person. So you can say that, well, I would think that if it is 80%, it's a good thing. Okay? So based on that, let's say there are 10.75, 0.50, 0.25 and okay, इसको छोड़ा reduce कर ले for our purposes. Because we are doing by hand, if you are doing by computer. So if these are the end, we come at the end of 4 hours. This is the end of 4 hours. This is state of charge. So we want to firstly put at the end. So remember I said airport se gate tak. So we are start from the end. So we'll always start from the airport our journey, and we'll optimize back. Okay. So यहाँ अगर zero state of charge hai, so if you are designing a optimization algorithm, how would you divert it? How would you nudge it away from 0 or from 0.2 or from क्या लगाया मैंने 0.2, 0.6 or whatever. So what is undesirable end? Okay, you don't want to end up at 0 and 0.2, or do you? जैसे मैम ने कहा कि 0.8, right? So आपको ज़्यादा चाहिए, कम नहीं चाहिए. So what can you do in an algorithm to steer it away from the values you don't want?
Reduce discharge rate.
Pardon?
Reduce discharge rate.
हाँ, पर एल्गोरिथम को कैसे बताओगे कि तुमने गलत काम किया है? See, that's the whole optimization process depends on your selection of how you will tell the algorithm not to do that. Yeah? Correct, आपकी बात सही है. तो वो टेम्परेचर अपन सिंपल प्रॉब्लम रखें. We just worry about what is the state of charge. We can also include, आपकी बात सही है, so what we will look into the scripts, or we have got things which look into all of that. But to understand the principle of dynamic programming, we do that. Okay?
Giving conditions, if we hit some certain limits, reduce charge or something, so that we can't drop zero
Yeah.
far away from it, point 1 or point 2.
Correct. So how do we tell the algorithm that? वो मैं पूछ रहा
By
हूँ.
using relational operator between SOC and battery charge, power.
So we need to take the operating points about the charging, depth of discharge.
Yes.
The highest charging point, that is 80% to 20%. The limits should be between that only.
100%. We will do that, okay? So this one is just a number, right? We can have 0.8 also, not a problem. But how do we tell the optimization program not to end up here at the end of 4 hours? Yes. So now all of you have got your point, and they're all valid point. So we have to assign a cost of ending at that point. So we assign a cost of 100 here. Assign a cost of 50 here, let's say. Assign a cost of 5 here. Assign a cost of 0 here. If you end up here, it will cost you this much. We are optimizing something, right? So we are optimizing the cost you pay, tariff you pay to the electricity company. So if you end up there, you will be paying 100. Okay? So now we do, so 4th hour, this is the 4th hour done. Now 3rd hour. Okay? So we have to get these 5 numbers. The cost to go at the end of 3rd hour, if my charging is 1 or 0.6 or 0.2 or 0, what is the cost to go? What action, okay, sorry. There are 3 actions, I'm very sorry. Actions -1, 0, 1. -1 you discharge, 0 you charge, and 1 you 0 you don't do anything. Discharge. Do nothing. So this is where we will understand this algorithm. So I have got numbers at the end of 4th hour, I have got numbers here. That is our state. State our system it is in, is the state of charge, the battery. So if I end up at the end of 4th hour at there, my cost is just 1. If I end up at 0.6, my cost is 5. If I end up at 0.2, cost is 50, and end up at 0, cost is 100. So this is telling that if you go there, the cost will be very high. So don't go there. So what is the optimal cost? You've got 3 actions. So let's start from here. You've got 3 actions. What out of these 3 actions, which will reduce the cost, the final cost? The cost, so from here, if you are sitting here and you want your cost to be minimum, what will you do? I have got charge of 0. I have got a charge of 0. I have got 3 possible actions. I have got 3 possible actions, right? So which action should I take to minimize my cost? The eventual cost. So cost, add this cost plus that cost of that column. Which action should I take? Which action should I take? I can do 3 things, right? Charge, discharge, or do nothing. If I do nothing, where would my battery be at the end of 4th hour? I am sitting down there. 0. What will be the penalty for that? 100. Can I discharge at that point? So, if I charge, will I reduce my penalty? If I charge, I'll reduce the penalty by 50. So if I'm sitting there, my action would be to charge, go to 50. Right? So my cost here, ध्यान दे, बहुत ध्यान दे. My cost here is 50 plus the electricity tariff I'll pay, which is 5 kilowatt. ठीक यार, हाँ. What is the load? What is the load between this if I charge? 5?
5 kilowatt.
If I charge,
Charging load will be different.
if I charge the battery,
5 kilowatt. 5 kilowatt.
5 plus 2. If I charge the battery, the load will be 5 plus 2. Right? So 3.5. So this is if I end up there, the best I can do is charge and my cost will be 53.5. Clear hai? Pardon? So this, if I charge, I'll end up here. Because 0.2 is my charge. So, well, नहीं मेरे को थोड़ी गलती कर दी. I can't escape that. 0, 5, 10, let's say, 0.6. I have to have 0.6 also. 0.4 also. 30. Because charging is only 0.2. So, thoda, sorry, I jumped a little bit. So, battery capacity. Sorry, I am very sorry. The battery capacity is 10 kilowatt hour. So, when you charge it for an hour, it gives you a charge or discharge at the rate of 2 kilowatt. It changes the state of charge by 0.2, right? So now अब आप मेरे को यहाँ जाकर get me the number here. So we will need numbers for all of this 1, 2, 3, 4, 5, 6. तो अब फिर if you have made it थोड़ा सा नया कर लें कॉपी में, घिसपिट नहीं, एकदम नया फर्स्ट क्लास. When you want to, believe me, if you are thinking of working in this area, you will continue to get doubts. What is principle of dynamic programming? If you do this exercise properly, you can always come back to it and try to understand what is the principle of dynamic programming. Okay? Pardon? 33.5. And what is the action? Charging, right? So the action is charging 33.5, right? And we keep going. Everybody got 33.5? Anybody who is not able to get that? Yeah, so 50 is the cost at the end. Once you reach there, the cost is 50.
Here we are calculating for 100% discharge.
No, not 100. So what we are doing here is that at the end of third hour, we could be in any of these 6 states. There we were at 0%. 0%. So we are at 0%. So what is the best we can do? If we don't do anything, the cost will be 100 plus 3.5. If you so cost will be 100 plus 5 times. So it will be 102.5. If you don't do anything, the cost will be 102.5. सब में वो केस आएगा, 3 केस आएंगे, right? Other than the 2 ends, you will have.
But sir, we are assuming only here charging one 33.5. मतलब at third hour.
Very good question. Very good question. मैडम आप उनका जवाब दें. आपने कहा 33.5. Very good question. Why are we saying 33.5 here? So maybe best is what we can do is I thought that's what you meant, comma 1. So comma 1 means charge. So the action is next. Zero तो नहीं होगा ना, आपको टैरिफ तो okay, this is a point worth discussing. So we have got 3 options. 30. We have got 3 options. Option 0, so we look at it in detail. Option 0. 0 means do nothing. So that means you will have your cost will be 50 plus 5 times 0.5. Right? Minus 1, discharge. So your cost will be 30 plus 7 times 0.5. Oh, it should be minus 1. Sorry. No, you are charging here, right? You are discharge the cost will be, I'm very sorry. Discharge the cost will be 100 plus this one. If you discharge at that point, where do you end up? Here the state of charge is 0.2. And if you start discharging, where would you end up? What will be the state of charge? 0. So your penalty is 100. So the cost is 100 plus 3. Sorry, I'm very sorry. Right? Is that right? And charge, it will be 30 plus 7 times 0.5. Right? Make sense? We have got 3 actions. We work out for each of these 3 actions what will be the cost to go. That's what technically they say, cost to go. And which out of these 3 you will choose? 33. Yeah, ठीक. एडमिनिस्ट्रेशन वाले के लिए 0.5 चलता है यार. Okay, so that's why 35 is written and it is charge. So do this for every node, all the 6 of them. This will be a great help to you when you are actually trying to do something this table. आप भूल जाएंगे. But since you have created this table yourself, you will always be able to recollect. When you see somebody else's thing, If you forget, it will be extremely difficult to recollect what they have done. But since you have done it yourself now, it will be very easy to recollect what you have done. सब कर दिया मैं all 6, all 6, all 6. Whatever, I don't know what it is, and then you keep going back. We have to do for all 4, all 5. 4, 3, 2, 1, 0. एक मिनट. No, battery is here.
Battery is not charging. That is discharging.
Oh, discharging. Sorry, मैंने गलती कर दी. Battery is discharging, so it will be 3, and here battery is charging, so 7.
In fact, 0, the first option, that 5 into 0.5 should be 0 into 0.5 because we are not doing anything on the battery.
अरे पर लोड तो सप्लाई करना पड़ेगा ना सर.
लोड तो आपने दे दिया ना.
हाँ तो उसके पैसे तो देने पड़ेंगे. कोई मुफ्त में लोड देता है क्या?
पर मल्टीप्लायर नहीं रहेगा ना फिर.
क्यों 0.5 तो होगा ना टैरिफ.
अच्छा, you are calculating theory.
हाँ तो करना ही पड़ेगा. टैरिफ इज एन इम्पोर्टेंट फैक्टर. टैरिफ पर किलोवाट. Because we are choosing 1 hour interval, so we don't multiply, otherwise we will have to multiply by the interval. Almost the entire reinforcement, learning, ये वो सारी चीजें इस पे निर्भर करती हैं. Let's do it in neat and clean and nice way so that it will be helpful for us forever and ever. At each instant, you will have 3 numbers. At each point, you will have 3 numbers corresponding to -1, 0, and 1. And you have to pick up 1. And same, you can keep going. Back, back, back. We have to go all the way back to 0.
At 0 tha, we have to discharge only.
At?
At 0 tha, we are saying SOC is 100%.
Yes.
So it has to be discharged only one action. We can't make other.
So, no, आप पैनल कॉस्ट देखें. डिस्चार्ज आप अपनी लॉजिक मत लगाएं. You look at the cost of all the 3 actions and pick up that action which has got minimum cost to go. आप अपनी लॉजिक ना लगाएं. So this is called cost to go. Cost to go. For each point you will have 3 numbers and we pick up that number action which gives us the least, the smallest number.
At third hour, suppose we get first stage, SOC is 100%.
Yes.
But we don't have previous rate, so we are taking 0 only first. At that.
Why? कौन सा क्यों नहीं है? You have to go all the way back. So first you have to fill all this. You have to fill all that. Then you have to come to second hour. Then first hour. Yes.
We are doing here.
Yes.
So we are taking previous penalty and adding the charging rate. And we
Yes.
are getting this number.
Yes.
Similarly, in every case, charging rate will have the least penalty plus this factor is constant at third hour.
The last time when you are doing nothing, the
So,
two
sir,
will what do?
actually in this we don't have previous rate.
क्यों नहीं है मेरे भाई?
Actually we are taking here 5. Suppose we are taking here 50.
नहीं नहीं कहाँ यहाँ आप हो?
हाँ, sir.
Zero charge है.
हाँ, sir.
So you can't discharge. You can't charge.
That's only I'm saying it has to be discharged only.
Yeah, correct. So that is infeasible. So we'll leave it out.
That only I'm saying.
Yeah, that's all right. You leave it out.
Okay, sir.
नहीं blank तो कुछ नहीं होगा. But suppose, see again let me repeat, here you can't discharge any further. So there will be no cost corresponding to discharge. Here you cannot charge. So there will be no cost corresponding to charge. So you will get only 2 numbers. Do nothing or discharge. When you are at the bottom, do nothing or charge. Yeah, correct. You are right there. Thanks. Sorry about that. हो गया मैडम? 6 पूरे 6 हो गए. ये क्या झंझट चल रहा है यहाँ? इधर से उधर पास सर. सो ये कौन सा है? विच वन इज? तो ये ऐसे बनाए ना टेबल मैडम, अच्छा सा सुंदर. See, again I will repeat, when you are here, right, you will get 3 costs and pick up the cost which is minimum. Yes.
For third hour,
Yes.
are these 3 options?
So अब सेकेंड आवर का कहाँ है आपके आगे?
ये इधर.
वो ऐसे टेबल में लिखे साहब. You have to write it like that nicely. You have to write it nicely. Don't write it in any other way. You do your calculations any other way, but put it in the table here. You have to put it in the table like that. There is no option. You do your calculation the way you want to do. When you are finished with calculation, the number should go here. Please write it as a table, no other way. कैसे चल रहा है?
सर ये 30 क्यों लिया? क्योंकि मतलब ठीक है यहाँ पे 50 हुआ.
Okay, so let's go this one, right? Okay, you want to know here. अपन हर चीज में आराम से करते हैं. जैसे I am here suppose at the end of third hour. हैं? तो तीन चीज कर सकता हूँ मैं, चार्ज, डिस्चार्ज और नथिंग. If I do discharge, I can't. If I do nothing, I will end up here. What is the cost there? 100.
100.
Or what is the cost I will pay to the company is 5 kilowatt multiplied by 0.5. Right? So उसकी cost होगी 102.5. Right? If I charge from here, right, I will end up there. So 50 plus what is the load I have got? Load 5 plus 2 7. 7 times 0.5. So this is 53.5. That's it. So यहाँ 53.5 आ गया. Charging.
ये दो समझ में आई सर. ये वाला 30 क्यों लिया जब चार्जिंग किया था?
कौन सा ये? This is done, finished, right? So now we come here. फिर story नई शुरू होगी. वहाँ से again you have to do the three things. Okay? So कहानी नई शुरू. So what is important is for every cell कहानी नई होगी. आप यहाँ का यहाँ काम में नहीं ले सकते. हर सेल की कहानी नई है. For every cell you have to evaluate the three actions. Charge, discharge, nothing. Find three numbers. Get the smallest number out of the three and write it here. Going all right? Well, remember for each cell you will get three numbers. No matter which cell it is, you will get three numbers. For each cell you will get three numbers. You have to put down the number here which is the smallest. Yes?
We are taking previous one as a penalty rate for charging. Next one is discharging. So how can we decide that?
अपन तीन नंबर आएंगे ना मेरे भाई.
That I understand.
So you pick up the number which is the smallest.
So we are not taking fourth hour as a penalty rate for us this hour.
Fourth hour, yeah, the cost to go. So remember always, here, this is the VNIT gate here. Then this becomes VNIT gate next. Then that becomes next. So you only worry about the cell immediately after. उसके बाद की कोई चिंता करने की जरूरत नहीं है. Third hour is the cost to go.
That is only my question. For second hour, what we have to take cost now? Third hour or fourth hour?
Third hour. Third hour. Just the next one. That's why you have to go populate a treble from right to left.
Actually, third hour my over.
Yes, the second. So you
Now this will be my cost.
exactly cost to go. Correct. Yes.
So Python script day 2 और day 3 का चलने लगा.
Okay, I
Day
will.
1 का दिखा सकते हो.
Okay. Day one, so MATLAB is going. Python is not working somehow. क्या? What does it complain?
एक्चुअली कोड में पूरा आउटपुट कॉपी करके लगा है.
Day 1 and day 2 files are ready, but today the file which was sent, na,
It's
this path error.
ये TensorFlow का error आ रहा
It,
है. ये फाइल पाथ से मैं चेंज कर सकता
yeah. I mean, what you need to do is you need to install this.
हूँ पैकेज.
Yeah, pip करके.
हाँ
हाँ,
सर
pick
नहीं हो
install.
रहा.
क्या कह रहा है वो?
Module not there ऐसा आ रहा है.
Where did you pip install TensorFlow? I could not find a version that's a requirement. Okay, so send the error to me. I'll send it to Nazrul. We can run it tomorrow, not a problem. Yeah. Yeah, day one का तो we can do. So वो तो MATLAB है, सब चला सकते हैं. So let's see. Yes.
Day one में ये भी Python course भी है.
हाँ वो तो उसमें that yeah that's duplicate. उसमें भी MATLAB भी. Yeah, we can run that today. That's all right. Not a problem. हो गया टेबल मैडम? नहीं अभी नहीं हुआ. या 0 तक जाना पड़ेगा, ऑल द वे टू 0. It's a repetitive, I know, I'm sorry about that, but some things are essential to do. We will have a good, satisfactory feeling only when we get the full table. Yeah. So?
That means the load.
Yeah, load, yeah, so that is, so between this is, yeah, so you can go only back, right? So between third and fourth hour, the load is this one. Between second and third hour, the load is 7 kilowatt. Between here, the load is 7 kilowatts. Between here is 5 kilowatts again. चल रहा है टेबल? Okay. This is the only, like steepest descent is the only way. So when you are doing hour 1 and 2 and all that, so you have to remember that the tariff cost is 1, and load is 7 kilowatt. So you have to use that information. See what I will do, you use Jupyter Notebook, right? So I will export the environment which I have got to run that, and then you should be able to do it. So that's what they say, you can export that environment. So you import that environment and you will be done. Okay. We'll try that.
These two columns will repeat, right?
Why? क्यों? No. जैसे आपने ये किया, फोर्थ का किया, राइट? ये फोर्थ, थर्ड का किया, टर्न, सेकंड का किया.
So I have between second and third the same 7 kilowatt. First and second again I have 7.
But it will add. So suppose you are 2.5 here, right? From here, you can do two things: discharge or keep same. So if you discharge, right?
Okay.
If you discharge is 3.5 plus 7 times or plus 5 times 1. Because you have to always add the cost you are paying to the electricity company. Yeah. So cumulative नहीं, अपने को उस hour का cost. If you are doing between second and third, the cost is 1 times 7 plus or minus whatever battery is doing. अगर बैटरी डिस्चार्ज है तो 5, बैटरी चार्ज है तो 9. हो गया टेबल सर? क्या, what is holding you? Okay, that's all. We will do it again. So what we are doing is, we have got 4 hours, 5 hours of load to supply. We have got tariff rates and we have got a battery. So when the tariff rates are high, we can kick in with the battery. That's the whole idea, right? So we are looking at the cost, the total cost, and we want to minimize that. So one of the cost factors we are considering is the battery state of charge. If the battery state of charge is low when we end up after 4th hour, we don't like it. So we are penalizing it. Big penalty. Right? Big penalty. Small. Now we want to calculate so this is the penalty. So now we want to calculate the penalty at the end of 3rd hour, what it will cost from 3rd hour to end up at the 4th hour. So if the rate of charge is this one, let's look at this. अगर नया आपको करता हूँ, अगर हम यहाँ हैं, the rate of charge is 0.6. So there are 3 things I can do. 3 things I can do. -1. So here we are. So -1, 0, 1. If I discharge from here, where do I end up? Next, अगर यहाँ से discharge शुरू करता हूँ, तो what will be my SOC at the end of 4th hour? 0.4. So 0.4 में आऊँगा तो penalty is 30 here. Okay, so 30 plus load है 5 and I am discharging the battery. So -2. Because load 5 है तो times tariff is 0.5. Then the second thing is Then second thing is I am doing nothing. If I do nothing, cost is 10 plus 5 times 0.5. ठीक है? Because load है, there is no battery, 5. Okay. Now the third thing is I charge. If I charge, I end up there. ठीक है? So cost is 5 plus 5 plus 2 times 0.5. ठीक है? तो 3 नंबर आए अपने पास. You pick up the number which is the smallest and put it there. And comma लगाकर action आप दे दो तो we know which action to take there. That's all.
Whichever is the lowest cost, you have to put a number.
Number there. So in that case, 12.5.
If we want to charge or discharge.
So and sorry. This is 7. So 8. Okay. ये है ना 5 है ना यहाँ तो 5 7 3.5 so 8.5 होगा ना यहाँ. हमको तो अपन डिफरेंट कर रहे हैं, आप कंफ्यूज ना करें. So then it will be charge. One is to say it will charge. So if you charge from there on, no matter how you got there, if you charge from there on, the cost to go, this is the cost to go. I am not calculating how much it will cost me to be here. But if I am here, my minimum cost is 8.5 with the action 1, which is to charge. And this is true for every cell. I can do these things. Right? But only top and bottom I can't, at the top I can't charge, and the bottom I can't discharge. So that you will get only 2 numbers. Everywhere else you will get 3 numbers. ठीक है? Anybody wants explanation again? I'll explain again. ये बहुत important point है. If you are in this business, you can always come back to this table and understand what people are saying because you have done it with your hand. और मेरे पास ये स्लाइड्स हैं अभी, वो आपके So we have to have some feel. Slides आपके पास आ जाएंगे. I will make sure that you get the slides. But वो slides का कोई मतलब नहीं है जब तक अपन ये, और इसमें there can be confusion, but it is very easy to sort out those types of confusion. That's all I'm saying. और जब तक आप ये टेबल पूरा नहीं करेंगे मजा नहीं आएगा. Yes, sometimes it is some very small things that hold you up. So I'm here to clarify that. अब हो गया समझ में? So fill those things in a table. Nice ऐसा अच्छा सा टेबल बनाएं. कैलकुलेशन एक जगह करें, वैल्यू दूसरी जगह रखें. हो गया? But same story everywhere. कोई अंतर नहीं है. Remember what is the principle of computer? Doing the same thing a million times. वो कंप्यूटर का प्रिंसिपल है. ये आपको जो मैं मेहनत कर रहा हूँ ये अडानी लॉन्च की देन है. वेटिंग इन द अडानी लॉन्च इन बॉम्बे, आई वाज स्ट्रगलिंग कि आपको कैसे ये बताऊं. हो गया मैम? नहीं होता रहेगा धीरे 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 धीरे. See, most of the numbers you can do it in your head. मैडम ये मेरे को मैडम कैलकुलेटर इसके लिए मैडम कैलकुलेटर इसके लिए
फास्ट होने से
फास्टर नहीं स्लोअर है So you have to remember here 3 numbers. यहाँ ज़्यादा so okay 3.5 5 plus Pardon? यहाँ ये 1.5 okay, third hour the load is 5 kilowatt and the tariff is 0.5 and you do nothing. 0 plus 2. Yes.
This is for third hour.
Yes.
These are the respective
Yes, good.
calculations.
So now we go second hour,
So
same
ये
story.
last वाला.
Yes.
If we do nothing,
Yes.
then this is 0 plus
Yes.
half into 5
Yes.
kilowatt.
Yes.
2.5.
Yes.
If we discharge, then we will come here. So
Yes.
5 plus 0.5 into discharge मतलब 5 minus 2 मतलब 3.
Correct.
6.5. And इधर चार्जिंग तो नहीं कर सकते.
क्यों नहीं कर सकते?
ये ऑलरेडी चार्ज है ना इधर.
नहीं तो आप तो कहाँ या करेक्ट.
तो दिस इज सेम हियर.
वेल इट इज नॉट फीजिबल. आप काट दो.
ओके नॉट फिजिबल.
नॉट फीजिबल. परफेक्ट.
अभी समझ में आ गया.
अभी समझ में आ गया ना. बार बार करने से समझ आ जाता है. We have to do that, sir. Huh? Yeah, this is 10.5, is it? So you charge, so 2.5, so 9, okay. 2 point, so you are charging, your cost is second to third hour, so it is 1 and 7 plus 2 is 9, right? So 9 and 2.5 is 11.5, right? The cost is 9, right? The cost, tariff cost, if you are charging. If you are charging, the tariff cost is 1 times 7 plus 2, 9. 9 plus 2.5 is 11.5. What? This one, why 2.5? Oh, 11.1. So maybe I made a mistake. So what if I charge? The total load is 9. 9 times 1 is 9. And the cost is 2.5.
9, how is it, sir? 9?
This cost is 2.5, right? When you charge, you end up here. When you charge, you end up here. You don't end up here.
Oh, how it is 9 charging? How it is 9?
Because 7 is the load and 2 is the battery. So 9
Charging.
Of course. They are also involved, they don't want you.
Please go ahead.
Join for a team. सब लोग सैचुरेट हुए होंगे तो जान लीजिए रिफ्रेश हो जाओ क्या ठीक है हाँ
काय होतं की
नहीं मेरे को और चाय चाहिए
चाय कॉफी
अगर नहीं है तो कोई बात नहीं
तुमसे मुझे बहुत सारी चीजें सीखने को मिली and now I am in the position of student.
Yes.
So that I can understand what students would have been feeling in my lecture.
That's the
To be very healthy. But the ये जो है ना fundamentally you are taking those answers directly जिसमें नहीं पढ़ना है.
you can make your life easy. Write the three costs at the bottom. 975. How quickly you can add and see. Team cost is 975. At every hour there is three costs. One charge, one discharge, one no charge. So 9 for charge, 7 for no charge, 5 for discharge. थोड़ा फटाफट आप कर सकते हैं. Okay, I mean, maybe I got something wrong, but the easiest thing is to write the 3 possible things at the bottom and then quickly see. You don't have to do a very detailed. Does that look all right? You got it that you don't have to write those things in detail. Just work out the 3 costs and mentally do which one will work. आपका 3 costs है, charge, discharge, note, do nothing. So just keep those 3 numbers in mind and do a quick mental calculation and you are done. Sorry, I didn't think of it before. I should have told you. जब थकान लगती है तो आसान तरीके ढूंढने जाते हैं. But that's okay. So now I would strongly suggest आप इसका picture ले लें या जो भी करें इसका, take a picture or whatever and complete the table. Is there anybody who has got doubt how to fill the cells? Maybe you are not filling the cell. Any doubt about how to fill the cells? मैडम कोई गलती कौन सा ये 22 होना चाहिए ये so इसमें कितना what is the cost so the cost here is discharge is 5 do nothing is 7 charge is 9 so 9 plus 13.5 is 21.9 right? ये गलती है हाँ 22 Thank you. Yes. This one. Second hour. First case. Okay, let's do it. Discharge is 5. Charge is 7. And do nothing is 7. It's 9. So 2.5 plus 7 is 9.5. So 9 here, 5 here, discharge, 8.5, right? Okay, thanks. Very good, sir. Thank you very much. But the whole idea is, I think, मैंने जल्दी में किया. But the idea is clear, right? What we need to do for dynamic programming. Clear, sir? इसको अभी confusion है to fill the cells? Yes, no? Please do it, complete it in your own time. और उसमें कुछ गलती मिले तो maybe just tell everybody in your WhatsApp group or something. Okay, so now what does this table tell us? That's what we want to do now. आप बताएं कि हमने ये टेबल क्रिएट किया, अब हमको इससे क्या फायदा होगा? What have we achieved by creating this table?
We can take the decision for a particular condition of the battery charge at the given loaded condition.
Very good, sir. At the given hour.
Given hour, whether
Yeah.
we want to charge the battery or discharge
Discharge
the
the-
battery or keep it.
Yeah, so the way the numbers have worked out is if you change the tariff cost and all that, these actions would be different. So if you do write a MATLAB script, which I think I have given you, आपके पास आ जाएगी वो, that will come to you. Battery dynamic programming or some MATLAB script is there. अभी अपन देख ले, we can look at it now. So now, if my battery status is this when I start with, I do nothing. Discharge here, right? If my battery status is this, I discharge here. If my battery status is this, I do nothing, charge, because this is, I have made it so low. So if you change these numbers, see what I want you to appreciate is that all this is dependent on your tariff charges, load, these numbers at the end. So these are the choices you will have to make to steer your algorithm to what you want to do. वो अपने आप नहीं करेगा कुछ. ये cost, these are some costs. So this is what it is said is with these penalties, with this tariff, this load, this is the optimal policy. Because at any given time, we don't know what is the state of charge. We are starting the whole process. We don't know the state of charge. We detect the state of charge is this, 0, then it is all the way charging. We detect this, so there is some discharging and then charging. We detect that, there is nothing to do, etc., etc. So these numbers will change, or this policy will change depending on these numbers I have chosen, depending on tariff, depending on power consumption. Am I making sense? So this is dynamic programming. अब इसमें कोई तकलीफ दिखती है? Why doesn't everybody use it? This is nice and simple, right? This is the only, this is the roughly the only principle used. So this is the policy, and we'll see in a few slides. So आप मेरे को बताएं, what is the problem you see in a scheme like that? Where would it trouble us? Why do we have all these great neural networks, etc., etc.? What is the limitation? अपन ने जो किया, from practical point of view, can you think of something? If things change, it might become too difficult to manage. How many states were here? In this, how many states are there? What are we monitoring? State of charge, right? And we have got 4 or 5 positions, and our actions are 3. Suppose you have got a control system, right? You are controlling a DC motor. How many actions have you got? You are controlling a DC motor, or you are controlling your EV or whatever you are controlling. How many actions have you got? No, suppose I am controlling a DC motor. Different type of application. I am controlling a DC motor. Start and stop. Good. होगा नहीं ना. अगर हमको पोजीशन कंट्रोल करनी है तो स्टार्ट स्टॉप से नहीं होगा.
Zero speed, maximum speed, and intermediate speed.
The control, अगर मैंने पोजीशन कंट्रोल करनी है, if I have to control the position of a DC motor, the position of the shaft of the DC motor, how many control actions are there possible? 3.
Clockwise, anti-clockwise.
तो आप उसको चालू बंद करते रहो, इधर जाए. So what is it you are using to control a DC motor? Remember, whatever control application you have thought of, suppose you are controlling a duty cycle, you are all power electronics people. Suppose you are controlling duty cycle. Right? So, I am controlling duty cycle. How many possible duty cycles are there? Pardon? नहीं अपन ने बदल दिया स्पीड कंट्रोल वो सब ठीक है पर maybe not everybody is familiar with DC motor application but you are all familiar with inverters in this cycle, right? So you control inverters using your duty cycle, right? So that is your control action variable, duty cycle 10, 15, 20. So how many possible duty cycles are there? So how many duty cycles are there? Possible duty cycles you can set. 3. What's meaning? How many duty cycles are there? So how many?
We have to take delta, how much we can vary, 0.01 range, 0.1 range.
So if I don't discretize, how many are there? Yes? Infinite. If I don't vary, so I discretize. Let's say I discretize. Like here I have discretized minus 1, 0, 1. Or I could have, here also in this application, the battery level could be, or battery charge discharge could be continuous. Right? So I have to test all of that for each action. If you are doing it for duty cycle, possible infinite, in the way our friend here says that we discretize it 0.2, 0.2, 0.3, so we have 10. Then let's see how it works. Right? So 10. Now, if you have DC to DC converter, it's a 4 energy storage element. So what will be the order of state? 4th order, right? So 4th order, and what are the possible values each state can take? Like duty cycle. What is the possible value each current or voltage in that device can take? Pardon? अरे current और voltage कितने level हो सकते हैं किसी device में? How many levels of current or voltages can be there in each device? Yeah? Pardon? अरे current voltage कैसे high low? वो तो infinite है, continuous range है भाई. वो थोड़ी हाई लो है. अरे करंट एंड वोल्टेजेस इन अ डिवाइस आर इनफिनिट रेंज. वो तो कोई भी हो, कुछ भी नंबर होगा वो. Right? So this is what is called curse of dimension. So that you can discretize that also, like you discretize your action, you can discretize your states also. But very soon you will find that the number is astronomical. Okay? The number is astronomical. So this is good for our understanding, and this is you should come to it again and again whenever you have confusion. Okay, I come to these things again and again. What is the alternative? Why did it suddenly pick up? As I said, Richard Bellman was pushing it in 1963 and he had computer programs, he did great things. But वो अपने जैसे लोगों के बस की बात नहीं. Recently it has been brought to our level. Right? Recently it has been brought to our level. तो क्या नई चीज हुई? नई चीज ये हुई कि this is a function, it is a policy. मतलब क्या कहूँ? Let me just look at what symbols they use. Okay, I think the symbol is this. क्या हो सकता है? When I use a symbol S, what would it tell? In general terms, when somebody uses symbol S in this business, what do you think? What does symbol A mean? Pardon? No, A, नहीं, A, what would it mean? अपन इतना कर रहे हैं, झंझट, A is for action, right? I'm just saying, I'm just asking you to guess, so I'm not told you. S is for state. S is for state, A is for action. What it does is, so now we have got a table, right? And this table you can imagine that if your this state of charge could be 0.1, 0.3 points, so you'll big with this one big. This table wouldn't do if you got more than one state, etc., etc. It will keep on exploding. This is a functional representation of this table. What does this table do? Given state S and previous action A, you come somewhere, this tells you what is the next action you can take, which this table tells you. If I am here, the action is 1. And you keep going. So maybe A may not be immediate here. Yeah. Sorry. Once I get my state S, it gives me my next action. This is the functional representation of that policy. As we discussed, neural network approximates a function. So when it is in a functional form, we don't have to prepare. So can we capture all these things in the neural network? Can we capture this table in the neural network? Can we capture this table in a neural network so that then we don't have to worry about the curse of dimensionality? Obviously, it is not needed to come up with that function. Books and books have been written. The functional form of the policy, it's not easy because you have to solve a lot of optimization problems, and in general they are non-linear with constraints, this and that. So people have found that all this can be captured in a neural network. Where? So how would the neural network look like implementing this function? आप बताएं, कोई भी बताएं. How would neural networks, so what is the neural network representation of this thing? So of course, the whole story, you are with me here so far. Okay, this is dynamic programming which you have to come back again and again to sort out your understanding. You will forget again, you will get confused. Have a proper one place where you can come back again and check your understanding. Curse of dimensionality, people at Google claim that they have overcome the curse of dimensionality by coming up with clever techniques to represent this table, which is a massive table, as a neural network. Got my point? They have been able to capture this very complicated function as a neural network. That is the biggest jump in our thinking. Right? But that's what you do all the time when you're using neural network, when you're optimizing, doing this and that. So what would neural network look like? बताएं आप कैसे, what will be the input to the neural network, what will be the output to the neural network? This is the function I want to neural network to represent this function. Is that
one easiest way is to use it as a lookup table?
फिर lookup table तो गया, काम खत्म. हो गया, वो तो अपन नहीं कर सकते, it is too complicated. But I want to, so this lookup table also can be a functional form, anything, any set of variables are related by a function, right? But we may not know that function. And in general, we don't know that function. But Google guys claim that I may not know that function, but I give you this neural network, and I will train this neural network to know the function. That's the claim. And that has been found justified in many, many different places. And that's what we are here to learn. Right? So all the background coming all the way here, this table you got, because of the curse of dimensionality, we cannot keep creating tables like that where the problems become complicated. And the functional form is very, very difficult to get when you have general problems with nonlinear constants, that everything. But a neural network can overcome all these issues. It can represent your optimal policy. So this is optimal policy. It is your optimal policy. Can be represented not only as a table but as a function. When I tell you a function, what comes to mind? When I tell you a function, what comes to mind? What is the image that comes to your mind? I say this is a function. So what should function have?
Dependent and independent variable, something must have to depend on something. Not y. Suppose we are telling y equal to x plus 1. We tell y is the variable dependent on x. So it is a function of x. It is a y function of x.
Yes. So we have inputs to the function, arguments to the function, which we provide, and that the outcome of the function are some values, right? Some type of values. In neural network, those values are real variables, or whatever different types you can have. So when I say a function, it has got input, it has got output, right? So how does I have got a neural network? And if I say this neural network represents the optimal point, what will be the input and what will be the output? Oh, sorry. Thanks. Right? What will be the input of it and what will be the output of it? I have written the function there. Yeah? Pata hai, madam? What will be the input to that neural network?
Input would be the states.
States. Input would be the states. Right? What will be the output? Actions will be the output. Does that make sense? Simple? So we have got a neural network where I put in state and it tells me what is the optimal action I should take. So if I put in the state here, the state 17.5 SOC, first hour, and it should immediately spit out -1. You go and discharge. So this tabular information can be captured in a neural network and then we can train it. How do we train it? That's the question, right? तो मुश्किल सवाल है. How do we train it? So let me see. This I have not tried before, but let us hope we will get it working. And finally, what does this theta stand for? We have got a neural network. So what would this theta stand for? So neural network, so it is, when I put theta there, what does it mean in general? It's dependent on something theta, right? So what is it in a neural network that theta will be? Will be weights, right? Because it depends on the weights in the neural network. So that theta will be dependent on the weights. So if I want to optimize this policy, I'll play with theta. What I'm giving you is the optimal policy, right? When we are training it, we play with theta and come up with the optimal policy. How do we know that the policy is optimal, right? How do we know that the policy is optimal? So I have seen it before, but I have not done it, but let's try it, hey? I hope this is simple enough so that okay. So 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 14, 15, 16. So there are 16 squares. And my target is to reach here. My target is to reach there in optimal time. And I don't know the maze, right? I don't know the maze. Only thing I know is, I don't know what the blocks are, but when I get there, it can't go there, and I will know that there is a wall there. So there is a wall here, I can't go there. There is a wall here, I can't go there. So how would it learn going from there? So it seems what they do is they reward. Let's look at the reward here. Reward. So reward here they say is 10. To reach there the reward is 10. And to reach any other cell the reward is 0. Because this is what you make up, right? This is your choice how to get there. Now, we start with all the rewards 0. All the rewards here are 0. To reach all these places is 0. This is the starting point. Excellent. So how is neural network trained? That's what I'm coming. That how do we get optimal values? So we have to train a neural network to do all this business. So the neural network, what it will have is the input will be the cell number, right? The cell number will be the input, and the output will be whether to go left, right, up or down. Our state is the cell number. Once you give it a cell number, the trained neural network will tell us whether to go up, down, left or right. So how is the neural network trained? They start, or you start from here. Let's say this is a starting point. You start from here and ask the question, which cell has got the highest reward? Which cell has got the highest reward? Right? Here the cells have the same reward, so it does not matter. So it will keep going, it will keep trying, random. So that's why randomness is very important. So randomly it will keep trying and get here. One day it will get there, right? Randomly it gets there. Once it gets there, it will get there from one of these cells. Let's say it gets there from 3. Correct? Let's say it gets there from 3, not 8. You can imagine, or it's not very hard to see that it can approach there from many different places. It can approach from one of the many different places. Right? Now, what will you do according to the dynamic programming? We did dynamic programming, right? As soon as I go from right here, I've got three options here. 3 left, 3, oh, sorry. Right, down, up, left. Okay? And I'm doing it randomly. I go to 3 and randomly I go to right. And then collect the reward of 10. Right? So what will be my reward value at 3? So okay, 2 things. So to prepare this table, what did I need? Sorry, 2 things I needed. What were they? To prepare this table, I needed 2 things. Tell me वो 2 चीजें क्या थी? नहीं, टेबल लोड प्रोफाइल ठीक है. इसमें क्या मतलब? Can you make it a bit more abstract? Correct. So state of charge, that's fine. So what we needed was the Q values or the cost to go of the next step, right? And the cost to go from here to there. That was the charging thing. How much tariff we had to pay. So 2 things we need. One is cost to go there. So here we can assume that cost to navigate is 0. There is no cost. So what will be the table value for this guy? 10. Right. Correct? So now we take the neural network. I get 10. Is there any confusion about this? Is done randomly. Once it finds a reward, 0, 0, 0, it will keep doing. There is nothing to be done. The output is our estimated. This is 0. So as soon as it finds that 10, it will find the error. अभी तक 0 था यहाँ. Now it has become 10. It will use that error to update all the weights in the neural network, like we did yesterday evening, back propagation. So it will train, so neural network, as soon as it comes to this cell, it will be trained to go right. Because the reward is 10. Right? Similarly, you can imagine, so this will become 10 over a period of time. This will become 10. So it can, so you can have different policies there, but basically if you make it more complicated, you will have a clear path, etc., etc. But that's not important. What is important is that how does it know what is the cost to go? Okay, here we knew the cost to go, right? Here we knew at every instant the cost to go, so we added the fun. But in general, there are many, like the maze, that's the most important, famous application that it can learn to navigate a maze by itself, right? How does it do it? It does thousands of these simulations. And then with that simulation, it keeps updating the, so here I did not have cost to go and all that sort of stuff. The cost to go from one cell to another, you can put that cost. You can put many things. But the point is, as soon as it gets new cost to go, it trains neural network assuming that's the true cost. It does not know. It assumes that that's the true cost. And then it keeps doing that. And it does it 1,000,000 times. And finally it gets trained to implement this table as a function. That is the entire story. Convergence rate, all this is very important, and people continuously work on that, because how long will you take to train the neural network depending on how you navigate, whether you navigate this way, that way, whether you navigate randomly. So here there are many issues that at every point you have to make a decision to go left or right. So if you are stuck in a policy which you think is optimal, but it may not be optimal because you have not navigated the alternate routes. So there is something called exploration versus exploitation. So exploitation is you are using the previous best policy. Exploration is you say maybe this could also be better. You go and navigate that and all that. So all this big theory, big all that, but all is important. I'm not saying It's not, but this is the essential idea. You got the essential idea? Okay. ये कैसे आएगा? To get this on screen? Okay, thanks. Remember, the most important idea is the principle of dynamic programming is what is used repeatedly. What we did in a table, that will always help you to clear any doubts you might have later. But we did it for a simple problem, that's all right. It is done for complicated problems, but okay, this I requested our friend Ala, he just finished his PhD, to prepare these slides for me. For 3.5 years I couldn't catch him to explain me things properly. So I said, now you have to explain things properly to me. So I've been working for the last 1 month on getting the scripts, understanding what it is doing, what he is doing. But still I am not totally in agreement, or not, I shouldn't say what in agreement. I not always get it. I don't get it, still don't get it, what he claims to be the thing. His claim is right, and this is what people claim in the literature. Partially I have seen it partially, but not totally. So let's do one thing, hey? Okay, that's all right. So upon bookmarks. Where are bookmarks? I think you have got slightly different than I have got. Bookmarks kahan hai? Bookmarks. यहाँ. Text. The one I have got, the latest one, the bookmarks are on the right. The 3 dots तो नहीं होगा. Anyway, I'll find it. That's not a problem. Yes. So how did you get it?
On corner.
Okay. Let's look at the simplest thing we have already done. Right? This is a MATLAB script with you. So MATLAB is in general easier to play with. Okay, so let me open that. Okay, 2-3 चीज अपन करते हैं अभी हैं. So escape. Can I go to the file folder? Okay, yeah. Okay, this is the MATLAB script I have got. Battery down, yeah. That's good. Okay. Yeah, that's. Yeah, just run it. Yeah. Okay. So this is what you see on the screen is exactly what I did. What we did as the process for creating the table, I did it using a small MATLAB script. Right? Same thing, exactly the same thing. No, but the idea of MATLAB script is you can play with the numbers and all that. So this is, oh, the green is not, oh, so this is the green here. Okay, green here, red there. So red is the load and green is the, and that's the peak hour. So between this and that is the peak hour. So you can see that the battery discharges during the peak hour and charges during off-peak hours. So simple, there is nothing too dramatic here. But this is the MATLAB script you have got, and you can play with it. Only thing I'll remind you is, okay, so we go there. No, this is all right. This is all right. This. So now we have to go. Okay, so this is all right. This script is with you. You can play, and you see here. So you can see the screen. So I have done the cost. I have varied, and the load and all that. All these things you can vary. You can vary the penalties and run this script. So what all we did, these three. You remember we had three actions. So this line just says that choose the minimum of the three. So this chooses minimum of the three, and then you keep going, okay? Then you populate the table. Done. So once you populate the table, you got the policy. No matter how you start, you can do that. Now, okay, so now we go to the folder for today. Folder. So we open that MATLAB script. No, day 4. Yes, down here. Then you open the script, reward. Yeah, reward test. Yeah. Okay. So this script is there with you. You can do everything possible. Oh, what I want to show is, okay. 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 See, training you see here, training 1000. So when you are trying this, make this training 10 or 5 or something, otherwise it takes long time to finish it. So if you want to check the syntax, if you want to try to understand what's happening, just make it 5 or 10 or whatever, so that it does not take that long. Otherwise this training, might take 10-15 minutes to train. Okay, and this is what we will look at right now, peak shaving. Okay, that example that thing we will look at, but you have got a MATLAB script to verify everything which is said in those slides, right? You do that, and just that, run that, and then little bit here, little bit there, and these are all MATLAB modules. So if you do it, you started running it. Unrecognized. How is that? जब वो उसमें फाइल होनी चाहिए. Let's go back to the folder. ये है ना फाइल. So maybe the search path is not right. So leave it now. We don't run it because it might take time. Yeah. So it will run. So run it with small number of training samples and then play around with it. So it will be very useful for you. If you change the tariffs, if you change this, if you change that, you can see how the policy changes. Okay. Okay. Up slide पे चले जाए. Oh, you use edge for that. Okay. Okay. So this is the example of peak shaving, right? All of you have heard of that, right? How to reduce the peak during the daytime. वो बहुत बड़ी चीज़ है, right? Peak shaving. So how do we use this reinforcement learning? So this is D for deep, R for reinforcement and learning. Deep reinforcement learning simply means that you are using a neural network with multiple layers to represent this function, that pi I had there. Okay, that's all it means. Okay, so let's go to first also. Okay, just I made you aware of the script, but let's look at the claims made for reinforcement. Okay, so this slide, so not only this slide has got these details, but you have so first two cases you have got a Python script, and the third one you have got a MATLAB script. So very powerful tools now you have to experiment with. It's very important to experiment yourself. So that's why I'm trying to cover the principles here, but that experimentation has to be done by you. Okay? Okay, so this we all are sort of familiar with. Maybe magnification, if you can reduce, we can cover one at a time. Yeah, that's fine. You can see, yeah? You can see, all of you? Okay. Okay, so this is so now this dynamic programming which we did, which was all right, but the point is that it may not learn the table which we have got have to be redo the table every time we change the tariffs, every time we change that. Now the claim of reinforcement learning and all this is that it adapts to the changes in the situation. That's the claim, right? And it is not so easy to completely verify it, but yes, through simulation there is some theory how it does that, etc., etc. How it learns. So that's the key. It learns it learns how to charge and discharge a battery, and it will do a good job of charging and discharging a battery even if the conditions around it changes, even though the tariff price changes. So it will take the latest thing. So the way it does it is the reward. So if the reward changes, and you can change reward dynamically, so it will adopt its policy depending on the reward. So I don't know anything, but tariff prices have changed. But what change has been there, I know. So I can immediately change the reward. It has got its policy based on the previous rewards. New rewards have come, and it has learned to deal with the new rewards and give you a different action. Once you feed the reward to it, reward is also, I took away the neural network there. Reward is also a part of the whole scheme. So you put a new reward, it will give you a new action. So as you keep going and the rewards, so this is what the biggest thing is. Handle uncertainty in price, load and PV generation. So if there is an uncertainty, how do we frame our policy? Okay, how do we frame? Basically, policy means a neural network. How do we train a neural network to take care of all these things? That's the big picture. Okay. Yeah, this is important classification. So, that was, sorry, this is what the symbol is. A dependent on S. So I just said A, S. So this just tells you, I wrote A on the left hand side. But this statement simply says that pi theta will give you A depending on what is S. A different way of writing. That's how they write. Okay. So now there is a value-based thing. Value-based thing is exactly like what we already did. Exactly what we already did. And then there is a policy-based. Policy is pi theta AS. So all this is neural network. So this is good. DQN and all these things are good if you want to do table and all that. But once you step in the domain of neural network, we are going policy-based thing. And actor and critic, it seems, Google claims, or its engineers or its programmers or whoever claim that this is powerful enough to handle problems with large dimensionality. So there is a critic, there is an actor who gives the action, and there is another neural network which takes the action and sees what is the cost of that action, and based on that they keep updating the network, right? So this is actor critic. Yeah. Okay, keep going. Yes, so that is the Bell-based dynamic programming. As I said, there is no escaping from that. So RSA, what we did before, what was RSA? In our case, what was RSA? See, we have done this today. We have formed a table just using that equation at the top. Bellman's optimality. So what was RSA in what we did? Pardon? But what was it in our case? Definitely. We have used RSA, right? So what was that RSA? Tariff. This tariff was there. So what I want you to do is whatever we have done to relate it to things like that. So we have tariff. So from getting, so S dash A dash is the new state, new action. What we have done, we have got one column was there, another column was there. So our cost was that second column, whatever is the optimal, and to go there. So added the two. How to go there and the cost from there on. This is what we have already done. Bellman's principle of optimality. These are fancy ways to writing that. Okay, so this is another fancy way to write it. Under policy pi, or when you remember pi, for our purposes, people in computer science are different. If you read the books, they will want you to assume that pi theta is a function. Okay, it's very hard for me to imagine what type of, they've got books and not yet say what is the exact function. Okay, but I suppose in their mind, or people who do this business, they have got several functions which can fit. But for our purposes, whenever you see that pi, just assume this is a neural network. You assume it's a neural network. So Q is the output of that network. And then, as I said, so we are optimization based on it. Yeah? So this is the error, as I said. So that is what you have, and this is the optimal cost. So there are all these factors there. Because so how did we look at the maze when we were doing? We are doing it randomly, right? So any value of Q we use, we are not sure whether it is really the right value or not, but we know that it is something better. So we use that, and that's why we have these forgetting factors, and there is whole story there. Then experience replay, that's another big thing. Where if you start at one place and have a trajectory, it is very likely that the same actions will keep happening. So what it does is, it takes a batch so take something from here, something from there, so it forms a batch to learn so that they are uncorrelated. So remember, we are dealing with random movements here, random things there. So if there is a correlation, it will not converge the right way. Okay, so keep going. That's this expression. Error, we have seen that before. And what is delta phi? What does that say? Gradient. So here they have used phi, it could be W. So gradient is always in our minds. People who are not computer scientists, people who are not Google engineers. Phi is, what would you consider phi to be? For our purposes. Weights. Phi will be the weights of the neural network. So don't get confused. For our purposes, you can assume that phi is the weight of the neural network and be done with it. Okay? So we are training the neural network weights depending on this error. This ST and QT, we get it from previous navigation. So I have navigated it before, right? So I know the cost. So I haven't done an optimal trajectory before. It was not optimal in the sense I don't know the thing, but it is still in some sense, out of the 10 trajectories I have done, it is optimal in that way. Right? There are infinite combinations. I have used 10 combinations of 100 combinations. So it is optimal in that way. Right? So I update it, I get an output, I use the previous estimate, update my weights, and then keep going my way. So this continuous update is what is called training. Okay, keep going. So that is simple, keep going. Again, so there are different ways to call it. One is loss function, one is to go cost, all these are there. So this is what we have been. So this is what Allah did his research, and his claim was that using this DQN, which is the popular technique, and coming to think of it, it is not any easier or harder than the other techniques he used, but the constraint violation was a lot here. Okay, when it is exploring, it can violate the constraint, and then to keep it within the constraint, he found it very hard. So we explored other methods. Please keep going. Okay. So these are the things. If I had enough time, I would take examples and show these each points to you. Okay, somehow we don't have enough time right now. So what it says is, the charge so this threshold, fixed thresholds ignore daily price dynamics. So we have trained it. So the DQN network, we have trained it, and if the price changes, it may not change its policy. Cannot adopt to changing load or battery health, often leave money on the table and risk associated. Money on the table means that it does not discharge fully, right? Because the charging, to keep it up at the right charge, the reward is so high, so it does not discharge and lower the cost. So these are limitations. So MLSP, so these are, so requires perfect forecast. Perfect forecast means it's the policy it develops has not learned enough about the whole process to give different actions when the conditions change. Okay, keep going. So this is slightly more So what is it we can get out of it? When you see that objective function, what is it that appeals to you? So this is for the optimal use of the battery for reducing the tariff prices or reducing the price you pay to the grid operator. For us, the design of this optimal function or this objective function is the most important thing. You know, design of this objective function is the most important thing. So what appeals to you in this objective function? Is it a reasonable one? Is it unreasonable one? That's all you have to look and say, is it reasonable? So what are the things you might want to change? If you are given this task, the programs are all written and you have to tweak this and run the program again, right? So what would you want to change? Just think of it from a practical point of view. So PT is the price you pay to the grid. I think he has used T because it is time dependent price. Then L is the load, and P charging or discharging. He has used two variables, but we could have used one. And then discharge reward. So what is discharge reward? Discharge reward is that if you discharge the battery, we will reward you. Because sometimes, like he says, money on the table, like what we dynamic programming we had, it was just charging, right? The table we had, because there is no discharge reward. If you include a discharge reward, it will discharge also. And the final is SOC, I want to be around 0.5. It is not around 0.5. I want to impose a heavy penalty. Other than that, is there anything else you would want to? Because at our level, these are the, keep going. So power balance is there, SOC dynamics is there. So all these things are there, but what would you like to change in the objective function? That is where the learning is, where you learn yourself. So we have got the script for you, and there is a place where you can change this. So maybe we can finally look at that HTML file is there. The other one. Code. No, same day 4. Okay. So codes, there is a 2 folder there, code folder. Codes folder, yeah. There is an HTML, DRL, something HTML. Yeah, that's right. Okay. So this is what script you have. So the whole idea is to create an environment. This gym is a library, or whatever you can say. It creates an environment. It does all the background thing for you, like what you are calculating this and that, it does for you. You don't have to calculate the table, go that way. Okay, keep going. So you give all the, keep going. Step, yeah, just come up to step. Keep step at the top. Yeah, no, just go down. Yeah, that's right. So the key function here is step. When you will look at this script, the key function is step, in the sense that it has to be executed every time you give an action. So when you have to take an action, the program calls this thing step, this function step, and this function step has got all the rewards and everything built into it. You see? So all the checks and all what we are saying, that if it is like that, it cannot go up, cannot go down. If P is greater than, so the mean price, so charge and discharging equal to max, the top one. If it is max, it cannot charge. So all those things which you are discussing are coded there, and then you have to code them, right? And this is the cost, this reward here. Reward here. So maybe we can increase the size. Yeah. Thanks. So this reward here. Yeah. So that is the main thing you need to give for this guy to get trained. Right? So you give the reward at each step. So whenever it takes a step, that minus cost battery, this is a reward. So we did this table, right? Just this morning we did a table. In that table, we had two things. What was that? Two things we had. Pardon?
Associate reward.
Yeah, so we had two things we added. One was the cost related to SOC, and that one was the cost to go from the next stage, and one was to reach the next stage. Right? So two things were there. That's why the table is quite important. Two things were there. So this is the first thing. Where is the second thing? Second thing is these programs have built in to remember that and do that. So we don't have to have that headache. They store that information. In the form of neural network or whatever, they store that information, and then they use that information. Only thing we have to provide is this reward here. So when you are playing with this script, what I would want you to do is that experiment with changing the reward. Experiment with, can we go down? Yeah, train, but that's it. Train and what? Yeah, keep going now. Yeah, that's it. Yeah. So here, 50,000. No, not 50. No. Test now. Model DQN. Buffer size. No. Before that, I think. Where it says how many times you have to do it. How many times? No. Train, advanced, terminal penalty. Keep going. I think train. Build and check. Environment. Yeah, keep going. It should have something here. Buffer size. Sorry. Here. 2000. Okay, total time steps 2000. So it says that you train yourself with 2000. I think he would have got, okay, he had 2 million. So I put 2000 here so that it is, I can check the syntax and things like that. So what I'm saying is keep that a small number so that you don't wait every time half an hour for it to converge. Then play around with all the other parameters to see what happens. So it will print for you the cost, this and that, etc., etc. Right? And it is doing basically what we put at the board as the table. It is doing that in the form of a neural network. That's what you have to remember. So you have to tell it the first part, and it will remember the second part. So we use 2 parts to do our cell. The first part you tell it, and the second part it will remember, because second part is mechanical. For every first part or for every problem, the second part is constant because it is from the previous iteration. So first part you tell it, second part it remembers, and finally it gets trained, and hopefully you get a reasonable response. So let's go to slides maybe final before we close. Okay, keep going. So we go to the plots. Keep going. So finally he will give plots out of this. Yeah, so this is the learning rate and all that, mean reward. So the reward, see, reward goes down, but it goes up again. So you have to be patient, up there. So it's like that, you know. Keep going. So that only, this. So these are the plots you get. So state of charge is this, your load is here. I think you should have put that on top because that's the input, the load and tariff price. Based on that, there's state of charge. This is charge, discharge. This green is the thing you pay to the grid. And the charging is blue, I think, and discharging is yellow. Pardon? Okay. So you get that picture. So it is, when is it charging? Can you tell me when is it charging? Or when is it discharging? Tell me. In that plot, when is it discharging? It is discharging in this time period. And in this time period, what is the tariff price? And the load. So tariff price is the highest and the load is the highest. So it is discharging when the tariff is high, the load is high, etc., etc. So what you should really do is, you should take this script, train it with one tariff price, change the tariff prices a little bit, and see how it performs. So all those things are to be done by an individual, and you learn it that way. Progressively you change this, change that, because nobody can do that for you. So you have to ask the right questions. So what has been done for you, a working script has been provided, which has been published. I think it has been accepted. All this work has been accepted for publications. So few people at least think that there is something new, something interesting in it. So that all research you have got with you, and you can experiment. And if these things work, we can have a tutorial tomorrow morning or whatever. So you can try to get these scripts. These scripts are easier to work on day 4 scripts. Okay, try that. And about the other script, I will export the environment and give to you. Okay, thank you. So I suppose we can stop here. Enough excitement for the day. Okay. Thank you very much.
Yes.
Water for me?
Yes, sir.